All right, the last section of chapter 8 we have is 8.4, which is really just going to be word problems with right triangle trig. So we still need to remember our SOHCAHTOA, and then we're going to learn a few keywords that will show up in these problems. All right, so let's start with this first example. We're just going to do a few on this sheet. We're definitely not doing the whole sheet as notes, okay? So number 1 says, a building 275 feet tall casts an 160-foot shadow on the ground. We're going to find the measure of the angle of elevation to the top of the building for an observer standing at the tip of the building's shadow. All right, that's a lot going on. Let's figure out if we can draw a picture of this situation. So I would first say we've got this building, and it is 275 feet tall. And then it casts an 160-foot shadow. So shadows are always along the ground. Okay, so there's your 160-foot shadow. And whenever we see this word angle of elevation, this is one of those keywords that we're going to hear today. We know we are dealing with a right triangle trig problem, so let's go ahead and make this into a right triangle. We've seen problems similar to this with Pythagorean theorem, but instead it's not asking us for that last length, it's asking us for the measure of the angle of elevation that's to the top of the building. So if I'm here at the tip of the building shadow, okay, then I'm looking up at the building. This is your angle of elevation. It's how much that you have to look up from the ground to look up at the top of that building, okay? So now the fact that I have two of these sides and an angle is involved, that's how I know this is also a right triangle trig problem. So let's go ahead and label our sides like we do with right triangle trig, and we'll go across from this x, and that is our opposite. And then this would be our right angle, because a building would stand straight up and down, okay? So over here is our hypotenuse, and we have adjacent. So now I can see that I'm using the A side and the O side, and that means I'm using tangent. So tangent of your angle equals O over A. All right, so the setup is always the same. Trig function, angle, and then whatever order, in this case tangent, it was O, opposite over adjacent, all right? So then remember, if we are finding an angle, that is where we use that inverse button of our trig function, so we use the tangent inverse, okay? And to get that on your calculator as a refresher, you use the second button and then hit tangent. And you'll just do second tangent of 275 over 160, and if you do that in the calculator, you get that angle is going to be 59.8 degrees, all right? So that is our angle of elevation. The trig is all the same, you just have to be able to draw a picture. All right, now let's look at number 2. This is another one that we're going to do together. So a 40-foot ladder is leaning against a building. All right, so I can already draw a picture just from that first part here. A 40-foot ladder is leaning against a building. So I've got a building, and here I've got my little ladder. Okay, and this ladder is 40 feet. The ladder forms a 70-degree angle with the ground. Okay, so let's draw the ground in here. And we know that's a 70-degree angle with the ground. How far is the bottom of the ladder from the base of the building? X. All right, so this one doesn't say anything about angle of elevation, but now that we've drawn a picture and we see that we're not dealing with all of the sides, we actually know an angle in this, then we want to use right triangle trig. So again, we start by labeling our sides. We'll go across from this 70. And there's our opposite. Across from our right angle is our hypotenuse, and the last one that's right next to it is our adjacent. So in this case, I know I'm using the adjacent side and the hypotenuse side. A and H uses cosine. So cosine of angle equals adjacent over hypotenuse. All right, so then you get x over 40 there. And now, if you're in my class, we say the variable is on top, so we times. So then x is equal to 40 times the cosine of 70. So the trig is all the same. The only thing we're adding in is drawing that picture. So then our answer, x is equal to 13.7 feet. All right? So this one didn't necessarily have that keyword that we know with right triangle trig. The picture is actually what told us to use right triangle trig because we had sides and angles involved. All right, now we're actually going to go to the back side and do a couple examples back there. We're going to do number 6 and number 7. So for number 6, I'll go ahead and write SOHCAHTOA up here too so we can use it for reference again. All right, so we've got a pilot flying over level ground at an altitude of 2,400 feet. A pilot flying over level ground at an altitude of 2,400 feet sights a building. The angle of depression from the pilot to the building measures 6 degrees. Find the ground distance between the building and the point directly below the pilot. All right, let's try to make a picture of this. So we've got a pilot, so they are in a plane up in the sky. All right, they are 2,400 feet off the ground. That's what altitude is. All right, and then they see a building. We'll call that our building. And the angle of depression from the pilot to the building measures 6 degrees. Find the ground distance between the building and the point directly below the plane. All right, so we are going to find this length right here. But now this angle of depression word, that's the second key word we're going to get from 8-4. So we have angle of elevation and angle of depression. These both tell us that we are going to be using right triangle trig. But angle of depression is a little bit differently. With angle of elevation, we were looking up. So with angle of depression, we are looking down. So that's because this pilot is up in the sky, so what they are seeing is this dotted line straight ahead, all right? And now they have to look down at this building. So the degree that they look down from their straight ahead view was 6 degrees, all right? So that is not a measure that is inside of my right triangle that I formed from this picture, but it can be, okay? Because the ground and his line of sight up here are parallel, so we actually have alternate interior angles that would put this 6 degrees right here, all right? So really, whether you have angle of elevation or depression, it's always going to be that bottom angle. But so we have that 6 degrees here, and now we can just use our right triangle. So I'll go across from my 6 degrees, and this is my opposite. Across from my right angle is my hypotenuse, and next to it is my adjacent, all right? So I can basically ignore all this up here. All I need to know is I'm using the adjacent side now, and the opposite side, which means I'm using tangent, and then you always put your angle, and then equals. Opposite is on top, because O comes first, which is 2,400, and then x is on the bottom because a is last, all right? So there's our trig function, and if you're in my class, we say if the variable is in the denominator, we divide. The d's go together, okay? Top times denominator divide. So we will actually say that x is equal to 2,400 divided by tangent of 6, and we will get that the distance, the ground distance between the building and the point directly below that pilot is 22,834.5 feet. All right. So the trig has not changed, but now we just have that new word. Let's do one more example with angle of depression, all right? So we have that right off the bat. The angle of depression from the top of a lighthouse to a boat is 27 degrees. All right, so we have this lighthouse. So from the top of a lighthouse, the angle of depression to a boat is 27 degrees. All right, because you are at the top of this lighthouse looking down at the boat. If the direct distance from the top of the lighthouse to the boat is 462 feet. Find the distance from the base of the lighthouse to the boat. Okay? So that's the length that we are going to find. I like to draw my picture as I'm reading the statement, add something new to it as I'm going, because or else it's a lot of information that they are giving you. All right, so again, I don't have an angle inside my triangle right now, but this 27-degree angle of depression will also be down here because of alternate interior angles. So I'll put 27 degrees, and then I will start my trig. So going across, or opposite of that 27 degrees, finding my hypotenuse across from my right angle, and then my adjacent. So I'm using the adjacent side, and the hypotenuse, A and H, tells me to use cosine of my angle equals adjacent over hypotenuse. All right, variable is on top, so we will times, number is always first. Make sure that angle stays with your trig function, so it has to be the cosine of 27, all right? And then we get that the direct distance from the base of the lighthouse to the boat is 411.6 feet. All right, so we'll go ahead and work on some more of these problems when we get to class, but make sure you have these 4 filled in that we did in this video.